Good evening. Can you all hear me?
Yes, ma'am.
Okay. So, shall we wait for a few more minutes? We'll wait for a couple of more minutes before we start. Okay, let's start. So, this is the second live class of the course. So, the course is Basic Environmental Engineering and Pollution Abatement. Is my audio clear?
Yes, madam. Clear.
Okay, so I think one of you has unmuted. So, can you please mute? Okay, thank you. So I'm Niketa, and I'm a PhD student from IIT Madras, and I will be one of the TAs for this course. So there are live sessions parallelly happening on Saturdays, and two sessions are happening on Tuesdays. So one is from 6 to 8, and the other one is from 7 to 9. You can join whichever one you want. Okay. So first, I hope all of you have watched the second week's lectures. So starting off with pollution. So can you tell me what is pollution? What is the meaning of this pollution? Any answers? If you want, you can even send me the answer on the chat box.
Ma'am, just harmful materials means harmful to the nature or environment.
Yeah, a pollutant is a substance which makes
Yeah.
something unfit for consumption, right? So when we say water pollution, we mean that something is there in water which makes it unfit for use. So, so that is a pollutant, and we can classify pollutants into two types. The first one being natural and man-made. So, like sometimes pollutants can be natural also. Like, for example, if there is, say, a forest fire happening, so that, I mean, the smoke and the particulate emission that is coming out of it can be natural. I mean, the source is natural. So, man made pollutants, we all might be knowing industrial effluents and emissions from industries. So, sewage, all of these are examples of man made pollution. And depending on the source of the pollutant, it can be classified into two types. So, the first one is a point source. So, can you all tell me what is a point source? So basically what we'll be doing in this class is I'll be giving you a brief of all the lectures and then we'll move on to proceed, I mean we'll move on to solve some questions. So the questions will be a mix of MCQs and maybe numerical type. Okay, so coming back, can you tell me what is a point source?
Pollutants created in industries like that.
Yeah, it is. Industries are an example of a point source. But
Chemical
apart,
industries,
huh? Hello? Yeah?
chemical factories.
Yeah, like those are examples, but I'm asking for the definition of a point source. What do you mean by a point source? You're right, industries are an example, but I'm asking for the definition. So, like a point source is something from which we can actually pinpoint that this is the source of the pollution. Okay, so suppose you have a huge piece of, I mean, imagine you have a big city and you have this industry here. So this is emanating the pollution. So you can pinpoint and you can say that this is the source of the pollution. Okay. Now the second one is a non-point source. What is a non-point source? Any answers? Okay. So in contrast to a point source, in a non-point source is something which you cannot determine. Okay. So for example, you have like you have a big industrial area, okay, from where you have many industries. It's a cluster of many industries and there are so many stacks. So and all of them are like giving out emissions. You can't really pinpoint and say the pollution is caused by one particular industry because it's like it's diffused. It's like there are so many potential sources and it is well distributed over an area, so you can't really pinpoint and say that this is the source of the pollution. So that's an example of a non-point source. And like what happens to the pollutants once they are released? So what are the possible things that could happen once a pollutant is released into the environment? Okay. So first, it could undergo dispersion. It could just disperse and it could spread out. Second one is dilution, meaning that it could spread and it could get diluted. For example, if you have a glass of, if you have a vessel having water and you pour a drop of ink, it quickly disperses and it just diffuses, right? It just mixes up and its concentration actually reduces. So that is dilution. The second one is deposition. Can you give me one example of deposition? Like, uh, maybe you've seen this happen somewhere.
The plastic waste depositions, like
Yeah, that is an example. So plastic waste deposited where?
means a particular region that
Sewage
yeah,
sludge. That is the pollutant, but where is it getting deposited? Okay, so I'll give you an example for this. Suppose you have a tanker, a ship containing oil, and there is an unexpected oil spill. So all the oil just floats on top, okay? But this oil is composed of, there are two kinds of oil, right? One is the heavy oil, and the other one is the light oil. So the heavy oil, what happens is, with time, it will sink to the bottom. So that is one example of how deposition happens. Okay.
okay, ma'am.
The last one is degradation. Now, when you release a pollutant into the environment, maybe a river source, it could get degraded by the bacteria. So gradually, its concentration will reduce and it will get degraded. So that is one possible fate. Okay. So then, there are also another category by which you can classify the pollutants in water. So water pollutants are mainly classified into these categories. First one is physical pollutant. The second one is a chemical pollutant. The second one is a chemical pollutant. The third one can be biological. And the third one can be biological. Can you give me an example for each of these types? If you're not able to unmute, you can even send me the answer on the chat box. So physical pollutants, they can be your dissolved solids, dissolved solids, suspended solids, etc. And chemical pollutants can be maybe the hardness, any heavy metals, or organic pollutants. Biological can be maybe different types of bacteria, pathogens, viruses, all disease causing microbes. Okay. So when we go to air pollution, in air pollution also there are two major categories of pollutants. gaseous, and particulate. Now, there is also one more category of microbial spores. Sometimes there could be some interaction between particulate and microbial spores also. Like, for example, microbial spores can get deposited on particulate pollutants and they can travel. So, now when it comes to particulate pollutants, there are two categories. First one is PM10, and the other one is PM2.5. So, can you tell me what are these two, PM10 and PM2.5? What does it mean? What are these numbers, 10 and 2.5? Any answers?
Ma'am, particulate matter 10
Yeah.
means 10 micrometers or less, something
Sorry?
like that. Means the pollutant in that will be a less than
Can you repeat?
means PM10 is particulate matter 10 micrometers or less in diameter, like
Yeah, yeah, that's right. So particulate, I mean PM10 means that the particulate matter size is less than 10 microns, and by size we mean the aerodynamic diameter. So PM10 means that the aerodynamic diameter of the particle is less than 10 microns, and PM2.5 means that the aerodynamic diameter of the particle is less than 2.5 microns. Okay. So then soil pollution. So it is mainly caused by the pollutants in water. Other than this, other sources of pollutants in soil could be due to agriculture. Like if we use a lot of pesticides, insecticides. So all of these can get deposited on soil, and because these things do not degrade, it will just continue to be there. Now, there is also another type of pollutant which is called a leachate. Can you tell me what is a leachate? Where does it come from?
in leaching
Yeah, leaching from.
leaching of a solute from the material by
Sorry.
solvent.
Yeah, but that's right. But we are, we are, since we are talking in the context of environment, I'm asking like, what do you mean by leachate? Which is, generally in environmental, what is a leachate? What you said is right.
Ma'am, the residues of the pesticides and chemicals we use.
Not exactly. So, okay. So, if you have a dump site, okay, where you dump all your solid waste, and what happens is over time, this solid waste will start getting biodegraded by the bacteria. So, when it biodegrades, it will release some water, okay. So, that water will form here, and it will percolate through the soil, and this water that is percolating is called a leachate. Now, sometimes what happens is during rainfall, because of the water falling on the solid waste, this leachate that is generated, it could be a mix of the rainwater and the biodegraded waste. So together it will come down and it can pollute the groundwater. So this liquid that is generated from rainfall and the biodegradation of solid waste is called leachate. Is that clear? Okay. So then, so these are possible sources of soil pollution, and this soil pollution is also linked with groundwater pollution, because most of the time, whatever pollutants are present in the groundwater will also get transferred onto the soil, and vice versa. Whatever pollutants are there in the soil can also get transferred onto the groundwater. Any questions so far?
Ma'am, can you tell any examples for PM10, the particulate air pollution?
Actually, there are no examples as such. Yeah, but one example can be that when you have a thermal power plant, right? So you are burning coal. So when coal burns, it will generate CO2, uh, maybe sometimes SO2, etc. And along with that, it will also generate something called a fly ash. Now, what is fly ash? Fly ash is just a particulate pollution that is emitted from the burning of coal. So this fly ash can be of PM10 or PM2.5. Okay. So when we see what are the impacts of these pollutants. So when we dump any waste or wastewater into water, especially in surface water, there is going to be a depletion in the DO levels. So what is DO here? DO is dissolved oxygen. So there is going to be depletion of and suppose you have a river and you are just putting some waste here at this point and it is getting polluted. So what will happen is imagine if this is your polluted zone. Initially, the profile will look like this. So when you have clean water till this point, the dissolved oxygen is going to be it's going to be somewhat constant. And assuming that it is equal to the saturation DO, so the concentration of oxygen in water is going to be around 9 milligrams per liter. Now, when we dump something or when we throw some waste into this river, what happens is this dissolved oxygen level will go down. Can you tell me why this happens? Any answers?
If we throw a waste on the river,
Huh?
the pollution will be happening the change in a color also happened, right? So the
Sorry, change in color.
means not color means the pollution will uh, dilute in the water, or it cannot the sunlight or clear.
No, actually, what happens is when there is a pollutant, especially when it is an organic pollutant in a river, there will be, as soon as it is introduced, there will be a gradual decrease in the concentration of your dissolved oxygen because there are bacteria present, right? So these bacteria will degrade the waste. And in order for this bacteria to survive, it will need oxygen. So the bacteria will use up the oxygen. It will use up the oxygen present in the river. So initially, whatever dissolved oxygen concentration was there, it is gradually going to go down because the bacteria is working. It is constantly trying to degrade the organic waste, and because it needs oxygen for survival, it is going to use up the dissolved oxygen present in the river. So that is why you are going to observe a decline in the dissolved oxygen level, and then it will come to a minimum point, and then again it will start. It will come to some minimum point, and then again the oxygen level starts climbing up, and it will come back to the original dissolved oxygen level. So based on this, we can classify the river into different segments. This is the segment of clean zone, and this is the segment where the pollutant is added. So there is a reduction in O2 levels, and because of that, since there is depletion in the oxygen, in this segment of the river, there will be the fishes that are present, fishes and other aquatic organisms like planktons will die because they need some minimal amount of oxygen to survive, which is not present. So in this zone, many fishes and planktons die. And this particular the next zone is called the septic zone. Can you tell me why it is called the septic zone? In this zone, the dissolved oxygen will reach a minimum, and because the dissolved oxygen level is very less, it is the lowest. So that is why anaerobic conditions will start developing. That's why it is called the septic zone. And when anaerobic conditions develop, what happens is you will have some foul smell, which is emanated from the release of methane and other foul smelling gases. So you will have a foul smell, and there won't be many fishes surviving. There only those fishes that are adapted to living in anaerobic conditions will survive. So and the next zone is the recovery zone. So here what happens is, after the bacteria has degraded completely all the waste, the the dissolved oxygen concentration will start to rise, little by little. So that will happen in the recovery zone. So here you will have some certain kind of fishes which are found in the pollution zone. So similar kind of fishes will be observed here. And then you have the clean zone. Clean zone is where you so the clean zone is where the river gets the oxygen levels are back to its pre-pollution levels. Okay. So this is the impact of dumping waste on in the water environment. So then impact on humans, especially human health. So can you tell me what impact pollution can have on human health? What can it cause?
Ma'am, it can produce lung disease.
Lung disease, yeah. So pollution can cause a variety of diseases. So maybe it could cause some skin damage or maybe lung diseases. So and also it could, it could also cause, contact with bacteria and virus are also more pronounced when there is a lot of pollution. So it can cause a variety of health issues in human beings. So when we were discussing about different kinds of air pollution, so we also saw gaseous pollutants. So one particular gaseous pollutant of interest is carbon monoxide. So what happens if we inhale carbon monoxide? So when we inhale carbon monoxide, it will bind to the hemoglobin and it will form carboxyhemoglobin. Now, generally, hemoglobin is used for carrying oxygen in the blood. Now, when carbon monoxide binds to it, it will no longer bind with oxygen, and hence the oxygen concentration in our blood will come down. So this could lead to asphyxiation. So there is a formula for calculating the concentration of carboxyhemoglobin. So So this is the saturation concentration of your carboxyhemoglobin, and beta is the 0.1 per percentage, 0.1 percentage per concentration of carbon monoxide, and T is your exposure time. And CO is your concentration of carbon monoxide. Other gases like sulfur dioxide can cause breathing impairment. And NO2 can react with organic pollutants to cause smog. Now, smog here is a combination of smoke and fog. And other pollutants like maybe the presence of lead can cause organ failure. So when we talked about soil pollution, we saw how what are the possible sources of soil pollution, right? So can you tell me what will be the impact of this soil pollution? How will it affect?
Yes, ma'am. The fertile land may become a fallow land.
Okay, that happens because of accumulation of pesticides and fertilizers. Okay. Any other answers? Can it have a direct impact on humans? Okay, sometimes what happens is if there are heavy metals in the soil, so these heavy metals tend to bioaccumulate. Okay. So heavy metals sometimes will get bioaccumulated into the crops. So if you have arsenic pollution and if you have a crop of rice growing, there is a possibility that arsenic will get bioaccumulated into the rice and it will enter our food system. Okay, now coming to the impact of noise pollution. So the impact of noise pollution can be classified into psychological and physiological. So psychologically, it could cause anxiety, stress, annoyance, and so on. So all these are psychological in nature. Physiologically, it could lead to hearing losses. Okay. So coming to the impact of pollution on the environment. So there are two phenomena that is happening. The first one is ozone layer depletion. So can you tell me what is causing this? What is the cause of ozone layer depletion? Okay, so can you first tell me what is ozone layer and why it is
Due to refrigerant, refrigerant enter the atmosphere and
yeah, that's right. So our atmosphere is surrounded by a layer of ozone, which will protect it from harmful UV radiations. Now, what happens is when we have gases like chlorofluorocarbons and refrigerant gases, so these will react with ozone and therefore the ozone concentration in the layer will get reduced. So beyond a point of time, after a point of time, the layer will become very thin, and in some places there will be a completely depleted ozone. So in those places, UV radiations will be very high, and it is also very harmful. Okay, the second phenomenon is greenhouse. Second term is greenhouse gases. Can you tell me what are greenhouse gases and what do they cause? What is the greenhouse effect?
to block the harmful sun rays to enter the harmful sun rays to enter the earth.
Actually, in greenhouse effect, what happens is the sun rays will have a particular radiation called infrared radiation. Okay. So there are a group of gases called the greenhouse gases, which will absorb the IR radiation and they will not let it escape. So what happens is that it creates a barrier where the IR radiations are trapped. So when this happens, the temperature of the earth will rise. Temperature of the atmosphere will rise, and this is caused by a group of gases called greenhouse gases. So some greenhouse gases are carbon dioxide, methane, and even water vapor. Okay. Any questions so far? Is my audio clear? Is there any echo?
Ma'am, it's clear, ma'am. Ma'am,
Yeah.
ma'am, whether nitrous oxide, I mean NO2, doesn't come under this greenhouse gas, ma'am.
No, actually. Yeah, wait, once there is going to be a question on this. So later during the lecture, maybe we'll discuss more of that.
Okay, ma'am.
Okay, so next coming to air pollution. So in this we have a term called a plume. So plume is basically a parcel of air which is moving through the atmosphere. And generally, this need not be strictly restricted to air. It can also be water. I mean, plume is generally referred to any fluid that is moving through another fluid. So, in the context of air pollution, it could mean a parcel of air which is moving through the atmosphere. And the movement can be of three types. The first one being diffusion. So what is diffusion? Any answers? So when you have maybe let's say you have a river and on this side I'm just adding some pollutant. Okay, so imagine this pollutant is inside this circle. Now, if I take the concentration of a point right next to this circle, what is going to be the concentration of the pollutant there? So the concentration of the pollutant will be slightly lesser as we move away from the circle. So why does this happen? So the concentration of the pollutant is going to reduce as we move away from the circle, and this will give rise to a gradient. So as we move further and further away from this point, there is going to be a reduction in concentration of the pollutant. This will create a kind of gradient where here at the innermost part the concentration will be the highest, and slightly away from this it's going to be a little bit lower, and as we move away and away from this the concentration is going to be lower and lower until it becomes almost zero. So this is a concentration gradient, and generally what happens is in diffusion the pollutant the movement of the pollution that is caused by a difference in concentration gradient is called diffusion. It's not just restricted to pollutant or pollution. It is also restricted to any substance uh, which travels because of the difference in the concentration gradient. So generally, a substance will travel from the region of higher concentration to a region of lower concentration. Okay. The second type of motion is advection.
So advection is just
bulk motion. If you have a river that is flowing in this direction, so because of the river flow, there will be some velocity of the river, right? So this velocity will carry the pollutant from point A to point B. So this is advection. And then the third type of motion is convection, which is a combination of diffusion and advection. So when we are discussing about air pollution, there is a term called lapse rate.
So a lapse
Lapse
rate
rate
is
is the rate of decrease of temperature as we move higher up in the atmosphere.
And there are two types of
lapse rates. The first one is the adiabatic lapse rate.
So
Adiabatic lapse rate is the lapse rate of a parcel of air which does not exchange any heat with the environment. So there is no heat exchange,
and
adiabatic conditions are maintained. And can someone tell me what is the adiabatic
rate for dry air?
lapse rate for dry air? Approximately how much?
Ma'am, 6.5.
Yeah, but that's for humid air,
Okay, ma'am.
which will have some water vapor and moisture. So can you tell me what is the dry adiabatic lapse rate?
It's around 10, ma'am.
Yeah, correct. So it is around 10, and usually it's about 9.8 degrees per kilometer. Okay. The second type of lapse rate is the environmental lapse rate. So the environmental lapse rate is unlike the adiabatic lapse rate, the environmental lapse rate depends on the time and place. So the adiabatic lapse rate is going to be the same no matter what time of the day or where you are. Where the pollutant is released. But the environmental lapse rate is the lapse rate of the environment, which is dependent on the time and place. So sometimes in the mornings, your lapse rate is going to be different from that in the afternoon. So like you can actually so lab state is this, your variation of temperature with respect to height.
So as we
So
as the height increases,
the temperature is going to decrease.
so
Okay.
when you have a
So
parcel of air
when you have a
that is
parcel of
near
air
the
that is
surface,
near the surface,
near the surface of the earth,
near the surface
it's
of
going
the
to be
earth,
very hot. Then
it's going to be very hot.
as it moves
Then
upwards, what
as
happens
it
is
moves
it slowly
upwards, what
expands.
happens is it slowly
Because there is
expands
going to be a
because
decrease
there is
in
going to be
pressure
a
as
decrease in
we
pressure
move
as we
upwards to
move
the
upwards
in
to
the
the
atmosphere.
in the atmosphere,
And because the pressure
and
is
because the
less,
pressure is less,
it tends to
it
cool
tends
down.
to cool down.
Its volume will
Its
increase
volume will
and it
increase
tends to cool
and
down.
it tends to cool down.
So as it cools
So
down,
as it cools down,
as it moves
I mean,
upwards, its
as it moves
temperature is going
upwards,
to cool
its
down. So that is your
temperature is going to
adiabatic
cool
lab
down.
state,
So
which is
that
about
is your
9.8
adiabatic lab
degrees
state,
per
which is about 9.8 degrees per kilometers.
and when it moves
And
up, it is
when it
not
moves
going to
up, it
exchange
is
any
not
heat
going to
with the
exchange any
environment.
heat with the
So
environment.
it's just,
So it's just,
it's an adiabatic
I mean,
process.
it's an adiabatic process.
So next we will see about the different stability classes. So there are three atmospheric stability conditions. The first one is the unstable one.
Unstable one.
So here,
So
imagine
here,
you have something like this,
imagine
variation of temperature with respect to height. And this is your environmental lab state. So lab state is usually denoted by this gamma. So this line is the environmental lab state, and this dotted line is going to be your adiabatic lab state. So when you have a
like this,
parcel of air which is somewhere
variation of
here,
temperature with respect to height.
and this
And
parcel of air
this is
can
your
move upwards or
have a parcel
downwards
of air which
based
is
on the
somewhere
direction
here,
and the speed of the wind.
and
So imagine
this
that
parcel
the
of air
wind
can
is
move
carrying this
upwards or
parcel upwards
downwards
in this
based
direction.
on the direction and the speed of the wind.
Now when it
So
moves
imagine
up,
that
it
the
tends to
wind
cool
is
down.
carrying this parcel upwards in this direction. Now when it moves up,
I'm sorry.
it tends to cool down. I'm sorry.
So when it moves up,
So when it moves up,
because of wind,
I
it
mean,
tends
because
to
of
move
wind,
up.
it tends to move
And
up,
when it tends to
and
move
when
up,
it tends to move up,
it will lose some
it will lose
heat.
some heat.
But still,
But
this
still,
air parcel
this
is
air
going to be colder than
parcel
the
is going to
surrounding
be
air
colder than
because
the
your
surrounding
environmental
air
lab state is
because your
lower, which
environmental
means
lab
that
state is lower,
at
which
this
means
height,
that at this height,
the temperature of
the
the air
temperature of
parcel
the air
is higher
parcel
than
is
that
higher than
of
that
the
of the
environment.
environment.
So you can
So if
even
you can
draw
even
lines and
draw
compare.
lines and compare.
So here,
So
if
here,
you say
if you say
like this is
like this
T1 and
is
this is
T1
T2.
and this is
So
T2,
the temperature of
so the
the air
temperature of
parcel
the
is
air
T2
parcel is
and
T2 and the
temperature of the
temperature of
surrounding
the
environment
surrounding
is going to be
environment is going
T1.
to be T1.
So here you can
So
see
here you
that
can see
T2 is
that
greater
T2
than
is greater
T1.
than T1,
And therefore
and therefore
the
the
air
air
parcel
parcel
which
which
is
is
hotter than the
hotter
surrounding
than the
air,
surrounding
its
air,
density
its
will be
density will
lesser.
be lesser.
So it will
So
tend to
it will
float.
tend to float.
So it will
So
keep
it will
moving
keep moving
upwards.
upwards.
Similarly, if you
Similarly, if
have a
you
if
have
the
an
air parcel is
if the
pushing the
air
wind
parcel is pushing
downwards
the wind
in this
downwards
direction,
in this direction,
then what happens?
then what
This
happens?
T2 will
This
be less than.
T2 will be less than.
Imagine we are taking the
Imagine we are
height at this
taking the
point.
height at this point.
So
So
yeah,
yeah,
imagine this is
imagine this is
T3 and this is
T3 and this is
T4.
T4.
So at this
So
height,
at this
your
height, your
T3 is
T3 is
lesser
lesser
than T4.
than T4.
So because it
So
is
because it
lesser,
is
it will tend
lesser,
to
it
be
will
more
tend to be
dense
more
and it will
dense
tend
and it
to
will
move
tend to move
downwards.
downwards.
So
This condition is called unstable because depending on the wind direction, the parcel will tend to move upwards or downwards, and it will continue moving in that direction because your density is also going to be higher or lower. So there are two factors that are influencing the movement of the air parcel. The first one is your advection because of the wind direction and speed, and the second one is your buoyancy. Now the second type of stability is neutral.
So here what happens?
So here what happens is this is your environmental lab state, and
this is the adiabatic
this is the adiabatic lab state. So here also if we consider a parcel of air which is here, and if the wind direction is pulling this parcel upwards, so it will tend to move up, but once it reaches this point, it's once it reaches this point, its temperature is not going to be so different when compared to since the lapse rate of the environment is similar to the adiabatic lapse rate, so there is not going to be any effect due to the buoyancy, and there is not going to be any change in density. So once it moves up, and it will stay there. So similarly, the wind direction will pull it down, and if it happens, then the air parcel will stay there. It will not move upwards or downwards, because your environmental lapse rate is going to be similar to your adiabatic lapse rate. The next condition is the stable condition. So here, if this is your environmental lapse rate, and this is your adiabatic lapse rate,
so here
your adiabatic lapse rate is going to be higher than your environmental lapse rate. What this means is that if you have a parcel of air, parcel of polluted air, and the wind is trying to move it upwards, so it reaches this point, and at this point, the temperature of the air is going to be less than that of the surrounding air. So because of that, what will happen is it won't move up; it will come down. It will come back to its original position. Similarly, if the wind is trying to move it downwards and it comes to this point, at this point, your temperature of the air parcel is going to be higher than the surrounding air. So its density is going to be lesser, and therefore it will move back upwards, and it will reach the original point. So this is your stable condition. So can you tell me which of these conditions is favorable for pollutant dispersion? Any answers?
Ma'am, is that environment lapse rate?
No, I'm asking, we have three conditions, right? Unstable, neutral, and stable. So which condition is more favorable for pollutant dispersion and movement? If you have a pollutant, you have a stack which is generating this pollutant here, okay? So what condition is favorable so that this pollution is moving away and it is completely dispersed. So what happens in the unstable condition? I mean, your pollutant will, if the wind speed is pushing it upwards, it will tend to move upwards, right? It will keep on moving upwards because your as it moves upwards, its density is going to be less, and therefore it is going to be above the surrounding air, and that will help it move forward. But when it comes to neutral, in neutral condition, it will move up, but only if there is any wind. Otherwise, it's not going to go up. And in stable conditions, what happens is even though the wind is pushing it upwards, it won't stay there for long. It will come back down. So based on this, can you tell me which condition is suitable for pollution dispersion? Is my question clear?
When it is moving up,
Yeah. Which condition is more favorable for that?
I think when wind is blowing in upward direction, or when chimneys are installed, that
Yeah, wind is blowing upward, but I mean, it won't be moving it constantly upward, right? Wind directions will also change with time. So, other than this, what other factor can influence? So, the buoyancy is going to play a role, right?
First condition.
Yeah. So, when you have unstable conditions, the parcel will keep moving upwards, and it will keep on doing that until its temperature is going to be the same as that of the environment. So, this condition is more suitable for pollution dispersion. Okay. So, then we'll come to Gaussian dispersion model. So we use Gaussian dispersion model to estimate the concentration of the pollution at a certain time, at a certain distance, and at a certain height from the source. So the model equation is something like this: concentration equals initial concentration by So here, this is the concentration of the pollutant in concentration of the pollutant at ground level in grams per meter cube, and E is the emission rate, the rate at which the pollutant is emitted from the stack. This is given in terms of grams per second. So SY and SZ are standard deviation in horizontal and vertical directions.
So wind speed.
And U is your
This is the downward
This is the
distance
downward
from where you
distance
want to
from where
measure
you
the
want to
pollution.
measure the pollution. Y is the horizontal distance from the center line. and H is your effective stack height. So what is effective stack height? Any answers? Okay, so when we are using this formula, we need to use the effective stack height H. So do you all know what is a stack? Okay, stack is from where the pollutants are dispersed, especially the air pollutants. And
this is your
this is your stack height,
H,
H,
height of the stack.
height of the stack.
And
And if your pollutant is going to be coming out like this,
it's going to
it's
form a
going to
plume.
form a plume. It's going to form a plume.
And
And
the distance
the distance
from the top of the stack
till the center line of the plume is called your plume height.
So your effective stack height is a combination of
So your effective
the
stack height
actual
is a
stack
combination
height
of
plus your
the actual stack height plus your
so this
plume
is
height.
your effective stack.
So this is your effective stack height.
Now to calculate your
Now to calculate your plume height, you can use many
formula.
formula. So one of them is the Holland's formula, which was discussed in the lecture. And now coming to transmission in groundwater.
So
So groundwater is stored in
structures
structures called aquifers. Can you tell me what this means? What is an aquifer?
Any answers?
Any answers?
Ma'am, it contains fresh water.
Yeah.
Yeah. So aquifers are basically porous
rocks
rocks
which
which
contain
contain
fresh water.
fresh water. And most of the time, these aquifers are interconnected. So that will result in the flow of water from one rock to another rock.
One place to another place through these
One place
rocks.
to another place
So
through
that
these
will
rocks.
create a
So that
groundwater
will
flow.
create a groundwater flow.
And
And
the flow of
the flow of groundwater depends mainly on the one
factor
factor, which is called the hydraulic
conductivity.
conductivity.
So
So hydraulic conductivity is the relative ease with which the water can easily travel through the pores.
The flow of groundwater
Now the flow of groundwater is governed by Darcy's law. So can you tell me what is
Darcy's law?
the formula for Darcy's law?
Darcy's equation.
Darcy's equation.
So Darcy's law gives you
So Darcy's law gives you the relation between
flow rate,
um, flow rate,
which is represented by
which is
Q,
represented by Q,
and it gives you
the relation between flow rate and your hydraulic conductivity, K
times I
times
and
I
A.
and A.
So
So
here
here your K is the hydraulic conductivity. I is the hydraulic gradient.
and
And A is the cross-sectional area. So hydraulic gradient is when you have a path like this, for example. Let's call this point A. Let's call this point B. Now, because of the difference in the height, it will create a difference of head. So, because of the difference in height, there will be a potential energy difference. And because of that, generally, water will travel from a region of high energy to a region of low energy. So, in this direction. So, this gradient is called a hydraulic gradient. So, since potential energy is a function of height, so your hydraulic gradient I is going to be the height of point A minus height of point B divided by the length. Okay. So then coming to retardation.
So what is retardation in general terms?
So what is retardation in general terms? I mean, what does this word mean?
Not exactly in
environmental context. In general, what do we mean by retardation? If we say something is retarding something, what does it mean?
Ma'am, it's like slowing down.
Yeah, exactly. So retardation means slowing down. So here we are talking about pollution. So retardation means, in this context, it means the slowing down of the pollutant. So when will this happen? Suppose you have groundwater which is contaminated with, let's say, some heavy metal, maybe even chromium, and it is flowing through soil. Imagine this is the soil. So what happens is sometimes the chromium could get absorbed onto the surface of the soil or maybe the surrounding aquifer.
So because of this,
So because of this, it is not going to flow with the water.
After absorption,
After absorption, the chromium is going to remain here, and the rest of the water is going to flow as usual. So we are saying that compared to the flow of water, compared to the velocity of the water, the velocity of the chromium is less.
Is this correct?
Is this correct?
Are you able to understand this?
Are you able to understand this? Okay. So this compared to the concentration of, compared to the velocity of the water, the velocity of the pollutant is going to be less because it tends to settle down or it tends to absorb onto the soil. So this phenomenon is called retardation, and we have a factor called retardation factor, which is given as the ratio of the total contaminant in the aquifer. Which is a combination of both that in the water and the concentration of the pollutant in the water as well as the concentration of the pollutant in the surrounding soil. So this sum of these two concentrations is the total contaminant in the aquifer. This is divided by the contaminant, which is concentration of the contaminant dissolved in this groundwater. Now this ratio can also be expressed as the velocity of the water divided by the velocity of the contaminant. So if the velocity of the contaminant is going to be less, the R will tend to increase. Now, when a pollutant is introduced in, say, a river, so immediately what will happen? It will mix with the surrounding water. So in that case, suppose if the pollutant that you are dumping, the dissolved oxygen concentration is going to be very less, and let's call it the dissolved oxygen concentration of the water. And it is being dumped in a river which has a dissolved oxygen concentration, which is DO river. Now, when it is mixed together, the dissolved oxygen of the resulting mixture is going to be your dissolved oxygen concentration of the waste, and this is going to be multiplied by your flow rate of the waste plus dissolved oxygen in the river multiplied by the flow rate of the river. This is going to be divided by the flow rate of the river and the flow rate of the waste stream. Now, once it is completely mixed, if we assume that the initial concentration present in the river was equal to the saturation concentration, which is let's say around 9 milligrams per liter, then there is going to be a deficit because the DO of the waste stream was less. So that is why when it mixes with the river water, the resulting DO of the mixture is going to be lesser than the saturation concentration. So this difference between the DO saturated minus DO of the mix is going to be your DO deficit. So when we were looking at so when we were looking at the oxygen sat curve, so this minimum concentration, this is the point where your deficit is going to be maximum. And this deficit at this point is going to be your critical DO deficit. So similarly, you can also have an equation for the BOD. So BOD is generally represented as L. So the BOD after mixture is going to be flow rate of the waste stream into BOD of the waste plus flow rate of the river into BOD of the river divided by the sum of the flow rate of the waste stream and the flow rate of the river. So the rate of change of oxygen concentration in the river is going to be this term here is called the rate of reaeration. Can also be written as KR here is the constant for reaeration. So
after a point of time, there is
after a point of time, there is going to be
there is going to be an exchange
there is
of
going to be an exchange of
gases
gases
from the atmosphere to the river
from the
surface. So that is
atmosphere
why
to
there is
the
going
river
to be
surface. So that is why there is
re-aeration
going to be
or the
re-aeration
replenishment
or
in the oxygen
the
levels. So
replenishment in the
that
oxygen levels.
constant
So
is
that
given as
constant is given as
Kr.
Kr.
And this
And this D is nothing but the deficit. That is your saturation concentration minus the concentration of the dissolved oxygen in the river. So this equation is nothing but your rate of oxygen transfer is directly proportional to your deficit. And this Kr can be found using the formula. And the rate of change of DO in water can be given by this equation.
So what this means is
So
that
what this means is that the rate of change of concentration of oxygen is the rate of deaeration or the rate of deoxygenation minus the rate of reaeration. So this difference will give you how much oxygen is present in the river at any given point of time. How much oxygen is removed. Whatever deficit is available present at any given point of time can be expressed as the difference between the rate of deoxygenation and the rate of reaeration. At steady state, this equation will become and if we want to find the critical deficit, if we want to find out how much the deficit is there, that is D critical, we can use this formula. DC equals to KD into LA by KR minus KD into e power minus KD into theta C minus e power minus KR into theta C plus dA into e power minus KR into theta C. So what is this theta C? This is the time taken to reach the critical deficit. So it can be expressed in days, and you can just rearrange this formula to arrive at the formula for theta C. Okay. So are there any questions? Okay. Then we will move on to the questions. Okay. The first question is sewage is a type of wastewater which is generated from Can you answer this question?
All of the above.
No. The
Domestic sources, ma'am.
Yeah. Sewage is a type of wastewater which is Sewage is a type of wastewater which is generated from domestic sources. specifically, the wastewater that is coming from households and homes is called sewage, municipal sewage. Okay, next question. Agricultural runoff is a type of point source or non-point source?
Ma'am, it's a non-point source.
Yeah. So since agricultural area is widespread and therefore when there is a storm or there is a runoff, the pesticides or whatever pollutants are there in the agricultural land will overflow and it will go to the nearby areas. And since it is not one particular point where the pollutant is coming from, it could be it could be hectares of land together. So that is why it is called a non-point source, because it's widespread. Okay. According to WHO, what percentage of diseases are waterborne? Can you see my slide? Yeah, can you answer this question? According to WHO, what percentage of diseases are waterborne?
Ma'am, is that 70%?
No. The right answer is 80%. So we have diseases like cholera and typhoid, which are generated from water. Next question. Which of the following is a source of grey water? Can you answer this? Yeah, that's right, Hope. Washing machines are a source of grey water. Generally, grey water means sewage is classified into two types: grey water and black water. So, grey water refers to the sewage that is coming from, sewage that is not coming from toilets. So this will include washing machine water or maybe the water coming from sinks, etc. So all this will come under grey water. Black water will include the water that is mixed with feces that is coming from toilets. Okay. Next question is, which of the following pollutants causes methemoglobinemia?
Nitrate.
Yeah, correct. So nitrate will cause this blue baby disease, generally in infants, if it goes beyond the recommended levels. Which of the following is an oxidant that is produced during smog?
Ma'am, is that acetaldehyde?
No, that's not correct. The right answer is formaldehyde. So nitrate plus formaldehyde in the presence of sunlight will give you photochemical smog. So, which of the following is not a greenhouse gas? Nitrous oxide, carbon dioxide, sulfur dioxide, methane. So we were just discussing about the greenhouse effect.
N2O.
That's not correct. No, I think you are. I mean, there is a slight misunderstanding. I'm asking which of the following is not a greenhouse gas?
Sulfur dioxide.
Yeah, that's correct. So sulfur dioxide is not a greenhouse gas. The rest of them are greenhouse gases which causes global warming. Okay, so now, yeah.
Ma'am, I had a question. In that, you didn't say about that nitrous oxide does not come under greenhouse gas. Can you explain?
Sorry, can you repeat?
Ma'am, when we were discussing about greenhouse gas, why this nitrous oxide is not considered here? I asked you, ma'am. You said while we are discussing the questions.
Yeah. So nitrous oxide is a type of greenhouse gas.
Okay, ma'am.
Okay, so now we'll proceed to solve some problems. Okay, suppose you have a wastewater which is being dumped into the river, and I'll give you some parameters.
So there is a river.
And in that you are dumping some effluent. So the flow rate of the river is 15 into 10 power 6 meter cubes per day. And that of
the effluent is
the
0.75 into 10 power 6
effluent
meter
is
cube per day.
0.75 into 10 power 6 meter cube per day.
And the concentration of the
And
pollutant
the concentration of the pollutant
in the river water it
in
is
the river water it is
0.5
milligrams per liter. And in the effluent it is 500 milligrams per liter.
So can you tell me what is going to be the concentration of the pollutant
after the mixing? Can you tell me the formula? We just discussed this formula. Okay. So C mix is concentration of the waste stream into the flow rate of the waste stream plus the concentration of the pollutant in the river multiplied by the flow rate of the river divided by the flow rate of the waste stream plus the flow rate of the river. So, can you all substitute and tell me the answer?
So what
So,
is
what is
CW?
CW here?
Concentration
Concentration
of
of
the
the
pollutant in the
pollutant in the
waste
waste
effluent.
effluent.
Can
Can
you
you
tell
tell
me
me
what
what
is
is
the
the
concentration
concentration
of
of
the
the
pollutant
pollutant
in
in
the
the
effluent?
effluent?
It's 500 mg per liter.
Yeah. And what is the flow rate of the effluent stream?
0.75 into 20,000.
Okay. What is CR and QR?
CR is the uh, concentration of river and QR is the flow rate of river.
Yeah. Can you tell me those
Yeah. Can you
values?
tell me those values?
This one CR is 0.5 mg per liter.
Okay.
QR is 15 into 10 to the power 6.
So, what is the answer?
Can you give me the answer?
Can you give me the answer?
Have you all completed
Have you all completed calculating?
So the
Okay, so
answer
the
is
answer is 24.285 milligrams per liter.
Now
Now
notice
notice
how
how
this
this
value
value
is
is
higher
higher
than
than
the
the
concentration
concentration
of
of
the,
the,
I
I
mean,
mean,
this
this
24.285
24.285
is
is
going
going
to
to
be
be
higher
higher
than
than
the
the
pollutant
pollutant
concentration in
concentration
the
in the
river,
river,
but
but
at
at
the
the
same
same
time
time
it
it
is
is
less
less
than
than
the
the
concentration
concentration
in
in
the
the
effluent.
effluent. Okay.
Next question.
Next question.
So a
So a
coal-based
coal-based
thermal power
thermal
plant
power
is
plant is
emitting
emitting
sulfur
sulfur
dioxide
dioxide
at
at
1.1
1.1
kg per
kg per
minute
minute
at a
at a
stack
stack
height
height
of
of
60
60
meters.
meters.
Given
Given
that
that
the
the
wind
wind
speed
speed
is
is
5
5
meters
meters
per
per
second
second
and
and
stability
stability
class
class
is
is
class
class
D.
D,
What will
what
be
will
the
be the
concentration
concentration
at
at what will be the concentration of sulfur dioxide at 500 meters from the point of emission at the ground level?
So since it is stability
So
class
since
D,
it is stability class D,
your standard
your
deviation
standard deviation SY is going to be 35 meters and SZ is going to be 19 meters. So, can you recall this
Gaussian
Gaussian
dispersion
dispersion
formula?
formula? Can someone tell me the Gaussian dispersion formula? This is E by pi into SY SZ into U. So your effective stack height is 60 meters, which is already given. Emission rate is 1.1 kg per minute, which is, when we convert it to grams per second, what is the value?
We have the
emission rate given in kg per minute. If we want to convert this to grams per second, what will be the value?
So it's going to be 1.1
So it's going to be 1.1 into 1000 divided by 60 into 60, which is going to be 18.33 grams per second. And given that your distance is 500 meters, so x is going to be 500, which is equal to 0.5 kilometers. Y is 0. So concentration at 0.5 comma 0 is going to be 18.33 by pi into 35 into 19 into 5.
What is your Y?
What is your Y?
Any answers?
Any answers? Y is going to be 0 here.
Can you tell me what's the answer?
So this, can you tell me what's the answer? Final answer?
Can you all just calculate?
Can you all just calculate and tell me? Okay, so the answer is 11.9 into 10 power minus 6 grams per meter cube. Okay, so with this, we have come to the end of the session. So, do you have any questions? Okay, if you don't have any questions, then we can leave the meeting. So, thank you all for attending.